And so we showed you where one of these came from, right, with that proof right there. So let's go ahead now. Let's use these. So I got 6 of these that we can use today. Our sum and difference formulas. Again, they're useful for finding exact values for stuff that's not on our unit circle. So let's do, like, for example, sine of 75 on this first one. Sine of 75 degrees. Well, again, notice on our unit circle, we don't have a 75 degrees, so I can't find the sine value there, the y value there. But I do know that 30 degrees plus 45 degrees, I have a 30 and I have a 45 on my unit circle, right? And so I'm going to use the fact, so I'm going to use this top one, sine of x plus y equals, that's the one I'm going to use right there. So sine of, and you can have alphas and betas or x plus y. Sine of x plus y is sine x, cosine y, plus cosine x, sine y. And so the sine of 75 degrees, which is the exact same thing as 30 degrees plus 45 degrees is 75 degrees. Notice our x is the 30 and our y is our 45. So we just plug it into the formula. Sine of 30 degrees are x, 45 is our y. Cosine our x is 30, our sine is the y. Oops, sine 45, right? And then we just look on our unit circle and we're like, oh yeah, 30 degrees. Our sine, there's a half. Now I look at 45 degrees, my cosine, the x value there, square root of 2 over 2. Then I find the cosine of 30 degrees, the x value there, 30 degrees. And then I find the sine of 45 degrees on my unit circle, which is the y value of 45 degrees. And then we multiply numerator times numerator. So 1 times root 2 is root 2. 2 times 2 is 4. It looks like we got root 2 plus root 6 all over 4. So we found the exact value of the sine of 75 degrees. Right? So instead of just punching it into our decimals and finding the decimal for that, now we have an exact value for this irrational number, square root of 2 plus square root of 6 all over 4. Okay? Let's do another one here, cosine 165. So you're thinking of two angles on the unit circle that either add or subtract to give you 165 degrees. All right, so you're looking at your unit circle, pulling it up, and you're like, all right, what two angles add up to 165? We'll do the add first. And you can say, well, maybe how about 45 and 120? Those are both on my unit circle, and they add up to 165, right? Again, those are not the only ones, but we can use those. So we'll go ahead and use 45 and 120 to do this. So cosine 165 degrees, same as 45 plus 120. Because I have a formula for the cosine of x plus y, or the cosine alpha plus beta, right? I'm going to use this sum formula. So I'm going to use this one right there. Cosine x, cosine y, minus sine x, sine y. So our 45 is the x. The y is 120. So then again, I look on my unit circle. I say, well, cosine of 45 degrees, root 2 over 2. I look at the 120 degree mark right there, right, which is, and I find my cosine of 100. Whoops, I mixed that up. I'm sorry. That is negative a half comma root 3 over 2. Sorry about that. At 120 degrees. So the cosine of 120 degrees is negative a half. Then I look at the 45, sine of 45, the y value, root 2 over 2. And then I look at the sine of 120 degrees, root 3 over 2. And so we got negative root 2 over 4 minus root 2 times root 3, root 6 over 4. So the cosine of 165 degrees is negative root 2 minus root 6 all over 4. And there's your exact value for cosine 165 degrees. Let's keep going then. Tangent 105. So now you're looking on your unit circle. You're looking for two angles on the unit circle that either add up or that subtract to give you 105. And so I would think, well, I know 60 and 45 works, right? So tangent of 45 plus 60, 45 and 60 are on my unit circle. And then look up the formula, tangent x plus y. And you go and reference your notes here that have that is equal to the tangent of x plus the tangent of y all over 1 minus tangent x tangent y. And let's go ahead and plug it in. So we get tangent of 105 is tangent of 45 plus the tangent of 60 all over 1 minus tangent 45 tangent 60. Well, tangent of 45 is the sine over the cosine, right? So we know the sine is root 2 over 2. We know the cosine of 45 degrees is root 2 over 2. Plus, now I go to the tangent of 60. So again, I'm looking on my unit circle. I know my sine at 60 degrees is root 3 over 2, and I know my cosine is 1/2. This is all over 1 minus tangent 45, which is 1, right? Root 2 over 2 over root 2 over 2 times the tangent 60. Well, this will simplify to give you root 3. Okay, so what we got is we got 1 plus, again, I simplified this. This is 2 over 1 root 3 over 1 minus 1 times root 3, root 3. That's what the tangent of 105 is. But I got to clean this up a little bit. I got to rationalize it. I don't want to have a radical in my denominator, an irrational. So I go ahead and multiply this by its conjugate. So 1 plus root 3. If I do it to the bottom, I got to do it to the top too. 1 plus root 3. So this ends up being, go ahead and FOIL that. 1 times 1 is 1 plus root 3 plus root 3 plus square root of 9, which is 3, all over. Now FOIL this. That'll be 1 plus root 3 minus root 3 minus 3. Notice those are gone. And so we've got 1 plus 2 root 3 plus 3. So 4 plus 2 root 3. All over 1 minus 3, which is negative 2. So I'm going to take that negative up top. That'll change both of those signs. And notice the 2 goes into both of them. So this is negative 4 over 2 minus 2 root 3 over 2. So negative 2 minus root 3. That's what tangent of 105 degrees is. Negative 2 minus root 3. Okay. Now in this next one, we're actually going backwards. Notice I have sine 40 degrees cosine 20. That's my x and my y, plus cosine 40 sine 20, right? So think about it this way. Like that's like sine x cosine y plus my x is 40, so cosine x sine my y is 20. So I'm looking for the formula, because I don't have 40 and 20 on my unit circle, right? But I'm trying to write this as an exact value. I'm looking for the formula that has sine x cosine y plus cosine x sine y. Sine x cosine y plus cosine x sine y. And I'm like, oh, that's let me erase these. That's this one right there, right? Sine x cosine y plus cosine x sine y is sine x plus y. So this would be sine of the 40 degrees plus the 20 degrees, which is the sine of 60 degrees. So then I just look on my unit circle, it's 60 degrees, and my sine is root 3 over 2. So all this is root 3 over 2. All right, so let's keep going here. So we got cosine x, cosine y. So x is the 3 pi 10, y is the pi 5. So minus sine, that would be the x. Sine, that would be the y. So I'm looking for cosine x, cosine y minus sine x, sine y. Cosine x, cosine y minus sine x, sine y. So that'd be that one right there. So cosine x plus y. So we have cosine, because again, I don't have a 3 pi tenths or a pi fifths on my unit circle, right? 3 pi tenths is my x, pi fifths is my y. Let's get a common denominator, so times 2 times 2, so 3 pi tenths plus 2 pi tenths is 5 pi tenths, which is pi over 2. So then I'm just finding the cosine at pi over 2, which of course is just 0, x value there. Okay. All right, good time to pause this video on this one, tangent, and try this one as a u-try problem. So here we got tangent x minus tangent y over 1 plus tangent x tangent y. So I look again at my formula sheet and I'm like, oh, that's tangent x minus y. Well, the x here is the 50, the y is the 20. So we're finding the tangent of 30 degrees, which we know is the sine of 30 over the cosine of 30. And we know the sine of 30 is a half, and the cosine is root 3 over 2. So when we multiply by the reciprocal, 2 over root 3 here, 2's cancel. I got 1 over root 3, but then we do have to rationalize that. So it just ends up being root 3 over 3. All right, now what we're going to do is we're going to be given some pieces of information about alpha and beta, and then we're going to put it together with a sum or difference formula. Okay, so notice it's asking us, we want to find sine alpha plus beta, but we're given some information. First of all, alpha, sine of alpha is 3/8, and we know alpha is in quadrant 2. Let's draw that first. So I draw alpha into quadrant 2, and I go ahead and I draw its reference angle. So I'm going to use alpha prime, if you will, its reference angle, okay? And I use the fact that the sine of alpha is 3/8. Remember, sine is opposite over hypotenuse. All right, so they gave us the opposite side and the hypotenuse. So we have 3/8. I fill it in on my triangle. I go ahead and I find the remaining side. So a squared plus b squared equals c squared. 9 plus b squared is 64. B squared, 64 minus 9, 55. Square root, square root. Now I gotta be careful here because we're using right triangle trig for an angle alpha that's more than 90 degrees. So is it plus or minus? I got to get the sign right. I got to label this as negative root 55 because I know my cosine is negative in quadrant 2. So make sure you label that as a negative root 55, even though that's a side length there. Okay. Now we have one of the pictures. Now we're going to draw the picture for the beta now over here. Cosine beta is 12/13, and they tell us beta is in quadrant 4. Okay, let's draw beta into quadrant 4. Here's my beta rotation. I'm going to go right back to the x-axis. I'm going to draw my triangle. I'm going to use the fact that the cosine of beta, they tell me, is 12/13. Well, remember, that's cosine's adjacent over hypotenuse. So I use beta prime to fill in my right triangles. So cosine beta, so the adjacent side right there, 12, and the hypotenuse is 13, which means we got to solve for the remaining side. So 12 squared plus b squared equals 13 squared. Subtract 144. And b is, now it's positive x, negative y, right? So make sure you label this. This is a negative 5. So and then put it in, negative 5 right there. Okay. Now what we're going to do is, now that we've got this all filled out, we can finally get to the part that we want, which is finding the sine of alpha plus beta. So then we look at our sum and difference formula sheet and we write out the sine of alpha plus beta, we're told, is sine alpha cosine beta plus cosine alpha sine beta. All right, it's in my notes. Or if you want, you can also look on your reference sheet. They're all listed. Right here together. All right, we did sine. I used u's and v's. All right, so sine of u plus v is sine u cosine v plus cosine u sine v, or alphas and betas, whatever you please on that. Okay. All right, let's keep going. So now let's fill this out. We got sine alpha. So I was given sine alpha. It's opposite over hypotenuse, but they did tell us that. It's so 3/8. And then what's the cosine of beta? So we go over here to beta. The cosine of beta is the adjacent over hypotenuse. And we were also given that one. But here's the part that we had to figure out. The cosine of alpha. So back to the alpha now. The cosine of alpha is adjacent over hypotenuse. Sine of beta. Let's go over to the beta picture. Sine of beta. Beta is, sine is opposite over hypotenuse. And so we got 36, what's that, 104? Plus, negative times a negative plus 5 root 55 over 104. And so sine of alpha plus beta is 36 plus 5 root 55 all over 104. So we have it in exact form with the information that we were given. All right, how about establishing some identities now? So isn't that showing? That's supposed to be, I'm not sure why that didn't show up. There we go. Sine of 3 pi halves minus theta is equal to negative cosine of theta. So what we're going to do is we're going to work with this left-hand side and show that it's equal to negative cosine, right? So what I'm going to do is I'm going to use sine alpha minus beta, or sine x minus y, because I know that that is equal to sine alpha. Again, I just look at my sheet. Sine alpha cosine beta minus cosine alpha sine beta. So notice our alpha is the 3 pi halves and our beta is the theta. Okay, so let's fill it in. So this will be sine 3 pi halves cosine of the beta, which is theta, minus cosine alpha, so cosine 3 pi halves, and then sine of beta, and again our beta is theta. Okay, so we're just working with the left-hand side. We're just working with this side. So we've expanded it using what sine of alpha minus beta is equal to, and then filling in the alpha and the beta. Okay, so now we look at the sine of 3 pi halves, and we're like, oh, if I rotate here, my sine there is -1. My cosine theta, that stays the same, minus my cosine of 3 pi halves is 0. Well, 0 times anything is gone. And so we've got negative cosine theta equals negative cosine theta. So there we go. We just proved it, right, using a difference formula. Let's do some another couple of these. So here's another one. Let's establish this identity. So on the top, we're going to have to use the formula cosine of u plus v on the top, okay? Or x plus y, whatever you want to use there. Oh, boy, it's touching there. Come on. There we go. On the bottom, I'm going to have to use the sine of x, or u. I'm using u's here. U minus v. So I look up cosine u plus v, and I find that the numerator, that'll be cosine u cosine v minus sine u sine v. Then I look up the denominator formula, sine of u minus v, and that's sine u cosine v minus cosine u sine v. And our u is x, our v is 3 pi halves on these, right? Our u is x, our v is 3 pi halves. So now let's fill it in. So we've got cosine of x, cosine of 3 pi halves, minus sine x, sine of 3 pi halves, all over. Now I'll go sine x, cosine pi halves, I'm sorry. On the bottom, my v is the pi halves. Minus cosine x, and then sine pi halves. So we got cosine x. I know the cosine of 3 pi halves is 0, so that'll clear that out. Minus sine x. I know the sine of 3 pi halves is -1. And then on the denominator, I got sine x. Cosine of pi halves is 0. Minus cosine x. I know the sine of pi halves, sine at 90 degrees is 1. That's gone, that's gone. So we got -1 times negative sine of x. It's just sine of x. And on the bottom, I've got negative cosine x. So negative sine over cosine, negative tangent. There it is. We just proved it. Or we just established that identity, right? A couple more here. A couple more. How about this one? Sine x plus y. So let me expand that numerator there. So I know that's sine x cosine y plus cosine x sine y. This is all over cosine x, cosine y. Now that's a common denominator, so let me write this as sine x cosine y over the denominator. And then plus the second term, cosine x sine y over that cosine x cosine y. Okay. And notice how those cosines are canceling right there. And those cosine over cosine are canceling right there. And so you got sine over cosine, which is the tangent of x. And then over here you got sine of y over cosine of y. That's the tangent of y. There it is. Tangent of x is tangent of, whoops, that's supposed to be a y right there. Y equals tangent x plus tangent y. We just proved that one as well. All right. And one more. Let's go ahead on this next one. The more complicated side to me is this right-hand side. So I'm going to work with the right-hand side. So I got 1 minus tangent x tangent y. So 1 minus, now remember, tangent of x is sine x over cosine x. All right? Tangent of y would be sine y over cosine y. Over 1 plus tangent x, tangent y. Now what I'm going to do is I'm going to get a common denominator. So this is, right now it's 1 over 1. So I'm going to give it a cosine x, cosine y, top and bottom. Same thing down here. I'm going to give it a cosine x, cosine y over cosine x, cosine y. And so what I'll have is cosine x, cosine y minus sine x, sine y, all over that common denominator, all over cosine x, cosine y, plus sine x, sine y, all over this common denominator, cosine x, cosine y. And notice when I multiply by the reciprocal, those will cancel right there. And so we'll have cosine x, cosine y, minus sine x, sine y, all over cosine x, cosine y, plus sine x, sine y. And now I just look on my formula sheet, and I'm like, oh, cosine x, cosine y minus sine x, sine y is cosine x plus y. And then the denominator, cosine x, cosine y plus sine x, sine y, is cosine x minus y. And there it is. We just proved it, right? Because we were trying to show that it's equal to that left-hand side. So we have it. And we just established the identity, again, using these some different formulas. So this is just more tools in your toolbox to help you with establishing identities. Well, thanks so much for watching. See you next time.